All right, for 9.3, we're going to get more in depth on those 6 trigonomic functions and how they relate to right triangles and how to calculate them with your calculator. So, I don't know if any of you guys remember way back in your geometry days, but SOHCAHTOA was a way to remember how to do sine, cosine, and tangent with a right triangle. The O stands for opposite. So when you have your theta here, O is the opposite side. A stands for adjacent. So that's going to be the side that's right next to your angle. And then H is the hypotenuse. So that's always across from the right angle, or in this case, it's your radius. So if we were to make these fractions, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent based on these letters. So OH is what gave us the O over H. AH is what gave us the A over H. And OA is what gave us the O over A. So, in a triangle, SOHCAHTOA works. When you have it on your coordinate grid, Y is going to be your opposite, X is going to be your adjacent, and R is going to be your hypotenuse. So this is the same equations we looked at in 9.2. We have Y over R, X over R, and Y over X. And now cosecant and secant and cotangent are the reciprocal functions, so you flip. So instead of OH, it's HO. Instead of AH, it's HA. And instead of OA, it's AO. When it also flips the green fractions. So either of these fractions can help you solve the triangles. If you have a specific triangle, the SOHCAHTOA is just that traditional. You probably learned that in geometry. If you have the coordinate grid, the X, Y, and R will help, and sometimes the combination will help everyone kind of remember those. So I'm going to throw SOHCAHTOA up here. And we're going to see if we can find the 6 trigonomic functions for this. So depending on the angle, we're going to do our opposite and our adjacent. So A, we're going to do the ones with A first. So the 7 is going to be our opposite because it's across the way. The 24 is adjacent because it's right next to. And the 25 is H. So for sine, we need opposite over hypotenuse, which means we would need 7 over 25. Cosine A is adjacent over hypotenuse, so we would do 24 over 25. And then let's do secant A. Well, secant is the cosine flipped. Remember, each pair is one co. So if cosine was 24 over 25, this would be 25 over 24. Now let's look at angle B. So I think I can do this. Yes. All right, so if we're looking at angle B, this is our opposite. 7 is our adjacent. 25 is still the hypotenuse. So tangent is opposite over adjacent. So in this case, it would be 24 over 7. And then cotangent is the inverse of that, the reciprocal, so we'd flip it. And then cosecant goes with sine. So if sine is OH, cosecant would be HO. So it would be 25 over 24. Now, notice, I'm going to point this out really quickly. Here, cosecant B and secant A are the same. Because it's a right triangle, we're basing it off of 90 degrees. So if you're just switching the angle, you're going to switch the opposite and the adjacent. So that's why those are the same. It makes sense that they would be. All right. What did I do? We're going to take a break from the trig for a second, and we're going to look at reducing radicals. So you can't have an irrational number on the bottom of a fraction. So this will often be called rationalize the denominator. Really, we're moving that square root to the top. So we're going to multiply by root 6 over root 6. We're going to take whatever this radical is on the bottom and make it a fraction over itself. Then we multiply straight across. So 5 times root 6 is 5 root 6. And then square root 6 times square root 6 is square root 36. And if you take the square root of 36, you get 6. And 5 over 6 doesn't reduce. So now you have a rational denominator, and that is the answer that would be acceptable. So let's try this one. It's a little more complicated, but it's the same process. We're going to multiply by root 2 over root 2. So on the top, 7 stays. 3 times 2 is 6. On the bottom, 2 times 2 is 4. And then the square root of 4 is 2. Some people can skip this step in their head, and that's fine, but don't feel like you have to. So now we've rationalized our denominators. You're going to see why that's important in a second. Way back in geometry, you also probably looked at special right triangles, like a 30, 60, 90. 30, 60, 90 is a triangle with a ratio that always matches. The angle across from the 30 is some value. And then the side across from the 60 is that same value times root 3. And the side across from the 90-degree angle is that same value times 2. So using this ratio, now that we know how to find sine, cosine, tangent, we can find the sine, cosine, tangent, and above and beyond for 30, 60, 90s. So these are going to be special angles that help you. You're going to see these a lot. So you're going to want to memorize the ones in the green boxes. You don't have to memorize all of them because you can turn them into the other ones. In theory, you could just memorize the cosine and sine of each because you can turn that into tangent. Tangent actually equals sine over cosine. So it's up to you if you want to memorize this and just the cosine and sines, or if you want to memorize those 3. That's your call. So cosine is adjacent over hypotenuse. So for 30, we've got our adjacent here, our opposite here, our hypotenuse here. So A over H would be root 3 over 2. The secant is that flipped. So we'd end up with 2 over root 3. Here's where you have to rationalize. We have to get that root 3 off the bottom. So it'd be 2 root 3, and 3 times 3 is 9. Square root is 3. So that's going to be our secant. Sine is O over H. So this would be 1/2, which means the cosecant would be 2. And then tangent is A over H. Nope, O over A. TOA, O over A. So this would be root 3 over 1. Oh, nope, 1 over root 3. O over A. Let's go, Miss Ross. Okay, multiply by root 3 over root 3, and you get root 3 over 3 as your final tangent. If we flip this purple fraction, it's root 3 over 1, which just equals root 3. You try the 60s, pause the video, and then check back in when you're done to see how you did. Okay, so that was our 60. That was our 30. 1, root 3, 2. All right, so cosine. Well, first, O, A, H. So cosine is adjacent over hypotenuse, so it would be 1 over 2. Secant is flipped. Sine is O over H, so that's root 3 over 2. If we flip it, it's 2 over root 3. Rationalize that. You get 2 root 3 over 3. Tangent of 60 is O over A. Flip that. You get 1 over root 3. And if you rationalize that, it's root 3 over 3. So again, you really want to pay attention to the ones in the green box because these are going to help you later where you want your answers in exact form. You try the 45, 45, 90. It's called that because the angles are 45. So see if you can do that. Oh, well, I should probably put 1, 1, and root 2 here just to make our life easier. We're going to go with 1 because where they're ratios, it doesn't matter if that's 1 or 5. They will reduce to the same fraction, so we use the smaller numbers. SOHCAHTOA. So cosine, adjacent over hypotenuse, and it doesn't matter which 45 you pick because they're the same. So O and A are both 1. So this would be 1 over root 2. If you multiply, you get root 2 over 2. Sine is also going to be 1 over root 2, which becomes root 2 over 2. And then your tangent is opposite over adjacent, so it's 1 over 1 or 1. Now we flip those. So 1 over root 2 flips to root 2. 1 over root 2 flips to root 2. And 1 over 1 is still 1. So with the 45s, you really only have that one piece that you need to remember because both angles are the same. Using that information, reference angles are helpful. So here you could have a 45-degree angle. You could have a 30-degree angle and a 60-degree angle. All of those angles repeat. So you have a reference angle. Over here, if this is 45 degrees, you can use that to help you find the answer. This is quadrant 2. So you find whatever it is for the reference angle, the 45, and then know, okay, well, back to that chart we did in 8.2, cosine should be negative in quadrant 2. So going back to that, we're going to talk about how to find reference angles. If you are in quadrant 1, you're just going to use the angle itself because that's this angle. If you're in quadrant 2, you're going to do 180 minus that angle, and you'll be left with this as your reference angle. If you're in quadrant 3, where this is your theta, you're going to do that minus 180, and you'll be left with that as your reference angle. And if you're in quadrant 4, you're just going to do 360, which is the whole thing, minus that, and you'll be left with this as your reference angle. Meaning you can find those by the boxes you just memorized. If you have an angle that is greater than 360 or less than 0, you want to find the coterminal angle and then do the reference angle so that you start working with something between 0 and 360. So 218 is between 0 and 360, and it's going to be somewhere in here. So that's your third quadrant. So to find our reference angle, we're going to do 218 minus 180, which gives us 38 degrees. Then, if we were trying to find sine, cosine, tangent, we would do it of the 38 degrees and base our answer off the fact that the original angle was in quadrant 3. All right, let's look at 1387. Well, first we need our coterminal angle. So we're going to subtract 360, do it again, do it again. All right, we have a number, 307. That's going to be in quadrant 4. So to get our reference angle, we would do 360 minus 307, and we would use 53 as our reference angle. Okay, 5 pi over 6 is radians, right? So 5 pi over 6 is going to end up in, so 5 pi over 6. Well, 6 pi over 6 would be here. So 5 pi over 6 is going to be in here. So we're going to use radians. So instead of doing 180 minus, we're going to do pi minus 5 pi over 6. Get a common denominator. It'd be 6 pi over 6. And 6 minus 5 is 1 pi over 6. There you go. So if you memorized that circle from before, pi over 6 is equal to 30 degrees. But pi over 6 is 60 degrees. What am I doing? Pi over 6. It's not doing what I want it to do. All right, pi over 6 would be here. Yeah, it's 30 degrees. Okay, I was right in the first place. And we could do that. So anyway, sorry, I had a brain fart. So use reference angles to find the values. So 210, we want to find all 6 values. So 210, first we're going to find our reference angle. So we're going to subtract 180 and get 30 degrees. So now we can find sine of 210, cosine of 210, tangent of 210, cosecant, actually I'm going to put those over here, cosecant of 210, secant of 210, and cotangent of 210. So remember, 210 is in quadrant 3. So we're referencing 30. Well, according to our chart from a couple slides ago, the sine of 30 is 1/2. And then in quadrant 3, sine should be negative, so it's negative 1/2. Cosecant is that flipped, so it'd be negative 2. Cosine 210, so cosine was root 3 over 2. And it's quadrant 3, so cosine should be negative. Then if we flip it, we get negative 2 over root 3. And then once we rationalize that, it's negative 2 root 3 over 3. And then tangent is root 3 over 3. And in quadrant 3, tangent is positive. So when we flip it and rationalize it, we get root 3 over 3. No, I lied. It was root 3 over 3. So when we flip it, we just get root 3. You can try 3 pi over 4, or you can watch me do it. It's up to you. So 3 pi over 4 minus, or we're going to do pi minus 3 pi over 4, which with a common denominator would give us pi over 4, which is the same as 45 degrees, but it's in quadrant 2. So we're doing sine of 3 pi over 4, cosine of 3 pi over 4, and so on and so forth. Cosecant, secant, cotangent. All right. So now we're going to do those based on the 45. So sine of 45 is root 2 over 2. And in quadrant 2, sine is positive, so it's going to stay. And then to get the cosecant, we flip it, which ends up being 2 root 2 over 2. Cosine of 3 pi over 4. So cosine of 45 is root 2 over 2. But in quadrant 2, that's negative. So this would just be negative flipped. And tangent in the second quadrant is negative. So these are both negative 1. Make sure I did those right back on this table real quick here. 1 over root 2. Yeah, so my brain canceled. This 2 and 2 cancel, so it's just root 2. And same thing here. This 2 and 2 cancel, so it's negative root 2. So there shouldn't be too many. They're the same thing. So that's how you do that when you have to find all 6. Now let's try finding exact values. So if it says find the exact value, if it has a reference angle of 30, 45, or 60, you can actually get a half or a root 3 over 2. If its reference angle isn't one of those, you have to use the calculator. So let's see here. First, we might need to find a coterminal angle. Then we find the reference angle. Then we find the answer. So negative 240, we have to add 360 to that in order to get our reference angle. So it's 120. 120 is in quadrant 2. So we need to do 180 minus 120, which is 60. So it's one of these. So we can do cosine of 60, which based on that memorization would be 1/2. And in quadrant 2, cosine is negative. So that is the cosine of negative 240. All right, tan of 675. So first we need to subtract 360, and we get 315. Now our reference angle is going to be 360 minus 315, which is 45. 315 is in quadrant 4. 45 is one of these. So we're really doing tan of 45, which is 1. And in quadrant 4, tan is negative. So the tangent of 675 is also negative 1. Okay, 380. We need a coterminal angle first. We get 20. That's already between 0 and 90. 20 is not one of those, so we can just plug it into our calculator. Okay, so we're going to do sine of 20, and it gives us 0.342. So sine of 20 is 0.342, which means the sine of 380 is 0.342. All right, here, negative 80, or 850, sorry. We're going to add 360. We're still negative. We're going to add 360. We're still negative. We're going to add 360, and we have 230. So that's our coterminal angle. It's in quadrant 3. So we have to do 230 minus 180 to get our reference angle. And that's 50. 50 is not one of our 3. So we're just going to plug cosine 50 into the calculator. Cosine 50. We get 0.643. 0.643. And then in quadrant 3, cosine is negative. So that answer should be negative. Okay, secant, cotangent, and cosecant. We're going to start with the same process. We're going to find our coterminal angle. Then we're going to find our reference angle. And now our calculator only does the 3, sine, cosine, and tangent. So we have to remember that secant is 1 over cosine. So first we're going to find cosine 80. We're going to do 1 divided by cosine 80 in our calculator. So 1 divided by cosine 80 gives us 5.758. 7579. Wow, 59. Cosine 80. 1 divided by second answer. So this is another way to do it. 5.759. Good. So you try cotangent and cosecant. Pause the video and check in when you're ready. So 2 pi over 3 is in quadrant 2. Where was 460? 460 was in quadrant 2. So cosine should have been negative. Forgot that part. All right. Quadrant 2. So we do pi minus 2 pi over 3. We need a common denominator. Subtract. We get pi over 3, which in this calculator, you need to hit the mode button and change into radians. Otherwise, you could just say, okay, that's 60 degrees and do it at 60. I'll show you how we'll get the same answer. So cotangent is tan. So we have to do 1 divided by tan of pi over 3. So 1 divided by tan. Then I'm going to, inside those parentheses, do pi divided by 3. And I get 0.577. Yep, hold on. And then if I put my mode back in degrees and did the same thing, 1 divided by tan 60, I'd also get 0.577. So that shows you radius and degrees work. But 60 is one of our reference angles. So what's the tangent of 60? Well, tangent of pi over 3 is root 3. So the cotangent of pi over 3 would be 1 over root 3, which ends up being, root 3 over 3. And in quadrant 2, cotangent is negative. So this would be negative. All right, so this one, negative 4 pi over 3. So first, we need to add 2 pi to get a positive angle. So common denominator would make this 6 over 3, negative 4 plus 6, 2 pi over 3. Which you could do out again or say, hey, that's the same thing we just did. So we're going to use pi over 3 as our reference angle. Knowing that this is in quadrant 2. Cosecant is sine flipped. So 1 over sine of pi over 3. So sine of pi over 3 is root 3 over 2. So if you flip that, cosecant of pi over 3 would be 2 over root 3, which is 2 root 3 over 3. And quadrant 2, cosecant is positive, so that's our answer. That is the end of 9.3. Let me know if you have questions.